Good morning, everyone. We are Team RailSutra, and today we are here to present our solution. The problem we took was how do we use AI to precisely control traffic and maximize the number of trains that can run on a section of track. In simple terms, we are solving the headache of delays, bottlenecks, and the stress of managing a complex real time railway network. Okay, so the name of our app, our solution is RailSarthi. RailSarthi is an intelligent platform that acts like a sophisticated air traffic controller but for trains. Its main goal is to make railway scheduling completely seamless by optimizing the most difficult spots like junctions and crossings and making sure all timings are precise. How do we do this? We have focused on five key unique features. First is conflict free scheduling. We use graph algorithms to think of it as a detailed map of the entire network to assign platforms and timings. This ensures that two trains can never be scheduled to conflict with each other, even on busy single track corridors. Second is optimized passenger transfers. To travelers changing trains, we intelligently align connecting schedules to minimize their waiting time at stations. Real time adaptability. When a delay happens, RailSRC doesn't just show the delay, it immediately and dynamically recalculates the routes, platforms, and timings for every other affected train, ensuring smooth operations. Digital twin technology. We create a virtual mirror image model of the entire railway network. If a major problem occurs, like a junction suddenly closes, the digital twin simulates the disruption and automatically reroute trains through alternative paths before the actual disruption causes a major jam. Smart Insight dashboards. This gives railway operators a data driven cockpit to efficiently manage the entire network and make quick informed decisions. We have also made a process flow. So how does that go? First, data injection. We feed our core optimized engine with train schedules, track levelets, and real-time feeds about delays and operational changes. The core optimization engine runs over advanced algorithms. It stimulously performs two main functions. It uses graph algorithm to find a conflict-free optimized route for every train. It optimizes passenger transfer to cut down on wait times. This process results into a proposed schedule. Before it goes live, the digital twin is constantly running simulations. The proposed schedule then feeds into the analytics dashboard for the operators. Once approved, the final optimized schedule is broadcasted to both the train crew and the travelers. Now let's look at the technical perspective. So let's deep dive into the technical approach.
Okay, so for the technical stack, for the front end, we are using the React.js and the Tailwind CSS for the operator's dashboard. And to provide the users the passenger application, we will be using a React Native application. And also for the maps, we are using the Leaflet, which is a JavaScript library, and a map box. And also for the charts, we are using the React charts. For the backend APIs, we are using the Fast API and the JWT auth and gRPC. Also, we are using the REST APIs to communicate seamlessly. We are using the AWS tech stack and the Python tech stack for communicating the data to the servers efficiently. So we are using the Amazon managed Kafka and document DB so as for the storing the data and caching. Also, we are using the SageMaker to predicting the uh, traffic routes. And also, we are sending the notifications and communication through CloudWatch and SNS. Also, we are using the Prometheus for the data logging and monitoring. So yes, and also we are using the Docker and Kubernetes to containerize and orchestrate our application. Now let's deep dive into the integration approach. So how we will integrate this approach? So the train operators will look the dashboard will be hosted on the front end. So our front end will be served through S3 bucket and distribute using the CloudFront CDN, which will be connected to the load balancer and ECS project in the backend. Also, we will be having the document DB, which is the Dynamo DB, and also the caching, which will the Redis cache. And for the uh, real-time data streaming, we are using Kafka. And for monitoring and logging purposes, we are using CloudWatch and SNS as discussed earlier. So yeah, this is the complete technical approach of our system, and this is the app logo of the रेल सारथी. अब हर यात्रा समय पर.
Okay, so we have designed RailSutra to be highly feasible and viable. Now, how? First, technically achievable. We rely on modern, proven, and scalable technologies. Secondly, it's cost effective because we are using only open source tools. Majority, yes, we are using open source tools, and we can keep the development and licensing costs low. Secondly, it's scalable. We can easily start small with a pilot zone and gradually expand nationwide. However, we are also realistic about the challenges. The three major risks are system integration with existing systems like CRIS and IRCTC, maintaining data reliability for real time sensors, and achieving user adoption among passengers. But we have strategies to overcome these things. For integration, we can actively collaborate with Indian Railways for APIs, access, and system synchronization. For data accuracy, we will use redundant data sources such as both satellite and IoT sensors to ensure reliable real time updates. For user adoption, we will build trust with features like government backed KYC for security, use string data encryption, and provide multi language support and interactive tutorials. Now, what are the impacts and benefits of RailSarthi? So, by maximizing throughput and managing traffic precisely, RailSati transforms the railway experience for everyone. For passengers, they will spend less time waiting and face fewer sudden delays, leading to more reliable and smooth travel experience. This also means less crowding on platforms, making travel safe and more comfortable. For railway operators, our train crew, they will have less stress during peak hours, benefiting for predictive operational guidance and seamless rerouting information. For the environment, by avoiding delays and unnecessary halts, we reduce the idle running of trains, which means lower fuel and energy wasted, a direct environmental benefit. There is also a use case diagram for our train crew, as you can clearly see how it's benefiting them also. So this is our proposed solution. To make this solution, what are the references and researches we have taken are: first we have looked for on the government side like IRCTC, Exigo to see how they have designed the apps and what features they are providing. Then we deep dived it into research papers that what they are trying to convey. Then we did our own research work using AI, and then we made a demo website which we'll also show and explain here.
So this is our website of Real Sarthi. We have currently deployed on this on the AWS CloudFront, AWS S3 bucket, and distribute it through the CloudFront, and also attached the domain with it through Route 53. Yeah, so this is our dashboard where all the trains would be shown here, like the Shatabdi Express, and also show which train departure time, arrival time, and from this we will calculate if it is on time or delayed. Like we can also filter out which trains are on time and which trains are delayed. So yeah, so on time trains will be shown from here, and the delayed trains will be shown over here. If the train is delayed for more time, it will be rescheduled. So rescheduled trains will also be shown over here. Yeah, so this is the home page, the dashboard over here though. So here we will give the map. This is currently the static data, but over here we will be giving the map which will be showing the accurate data of the train. Also it will show that platform which the conflicts which our train are making, like platform conflict, the two trains arriving at the same time, like platform 3 and conflict between the arriving and departing trains. So platform conflict, track conflict will be shown over here, and rescheduling suggestions will be shown over here. So the admin can approve the reschedule or reject the reschedule. So this is our complete dashboard. So this is the route performance. We are showing the data. So what is the delay and what is the efficiency through here. So yeah, this is the simulation. We have calculated through this formula, like passengers into delayed minutes. So it will show how much minutes we have saved. And yeah, this is the data layer. This is our processing. This is the conflict detection, like track conflict, platform clashes, and schedule overlaps. And this is the performance distribution, like how much which trains are on time and which trains are delayed. So yeah, this is the all about the Rail Sarthi. Our mission is revolutionizing the Indian Railways through AI-powered smart scheduling and real-time rescheduling solutions. So hope you like it, and this is our solution for the Smart India Hackathon. Thank you.